Alright, I'm gonna start up this video. Hey everyone, got OG Paul in the building. We're gonna run through some coding questions. We're gonna do it meta style. Probably like we're gonna try to do two questions in the span of probably 20 to 25 minutes each question. Could you just give a background of like, well, maybe how many leak code questions you were at? Like, yeah, you're in a master's degree program and stuff, right? And maybe talk about
Yeah.
that and then yeah, like what companies are you aiming for?
Yeah, I'm doing my master's right now. It's like online, so I'm working as well.
Mm-hmm.
But uh, I don't know. Right now, probably like remote companies, so like Stripe, although they're
Nice.
kind of going away from the remote. So like Affirm is a company I'd want to work at. Uh, Places like that, or like Coinbase as well. But Coinbase probably wouldn't hire me realistically at the moment.
Why not?
I don't think my resume would pass like ATS because I've only been working in I'm working at a fintech company now, but it's only been for like 3 months
I see.
or 2 months really.
So what are your leak where are your leak coding skills at, you think?
I think I haven't leak coded a lot, but I'm good at like knowing what algorithm to use. I got 150 solves
Nice.
and probably like 50 or 100 in the past year.
I see. Okay. Okay, I like it. All right. What we're going to do here is I'm going to post in the first question. I give you around 20 25 minutes to solve it. Around the 20 25 minutes, we'll just move on to the next part and yeah,
All
we'll
right.
have the criteria at the end. So, the first question is you're given a n by n matrix rotated by 90 degrees. So, if this is the output,
Okay, so we're just rotating the image clockwise by 90 degrees, right?
exactly. So, you could look at this input
Okay.
and just explain to me why the output should be that.
Yeah, so effectively for this, we're just rotating 90 degrees. So if you're like familiar with, say, a tire, I'm just gonna draw um, another example down below that's probably easier to just, let me just move these numbers so it's easier to keep track of. Uh, so say you want to rotate this tire. This is like a circular shape. Are you able to see this, right? The
Yeah.
comment.
Yep.
Say you want to rotate this 90 degrees clockwise.
Sure.
You're going to rotate this one to here,
Okay.
and this is going to be what was here before. So it's going to be 3, and then 4, and then 2. So everything's going to be shifted 90 degrees that way. So in a matrix, effectively 90 degrees is switching from one corner to the opposite corner,
Mm.
or switching from, say, one wall to another wall. So effectively, it's just moving. So see, this 2 here is going from the top middle, it's going to the right middle. And then this is going from the top left to this one's going from the top left to the top right during the rotate.
Sure.
So the the implementation for, I guess, like the for numbers, just what you need to do to actually achieve this, at least the easiest way, in my opinion, is to first just do a vertical reversal, or a rotation rather. So effectively just rotate it over the center, a vertical line in the center, right? So say we're going to have the input matrix, and then we're going to have matrix middle, in this case, would equal 3, 2, 1, uh, 6, 5, 4,
Okay.
and then 9, 8, 7. And the reason we want to do this is so we can then afterwards do a simple transpose. And what a transpose is effectively switching the rows and the columns. And since it's in by in, we don't really have to worry about reallocating memory for a different size matrix or anything like that, since it's always going to be a square matrix.
Sure.
So basically, we're able to do this in place because it's a square matrix. So we're just going to switch from column right here. We have column 0, 0. We're going to switch that to effectively column. We're going to switch. Sorry, we're going to switch column 0, 0 with the opposite one. So effectively rotating it over a diagonal line, if that makes sense.
Mm-hmm.
Um,
You're gonna rotate it
or
over
I
a
guess
diagonal line here.
yes. One
Okay.
second. Let me just give me a second. No, okay. Sorry. I misspoke. Are you able to still hear me? I think my
Yeah,
headset might
I
cut
can hear
out.
you.
Okay, okay. I think I made a mistake here. So we actually don't want to do it we don't want to do it over the vertical center. We want to do it over a horizontal, since we're going clockwise rather than counterclockwise. Uh, so here, after we do the reversal, what we're gonna have is we're going to switch this row to the top, and this row from the top is going to be here. So it's going to be like this. And then we're going to do the transpose I was talking about. So we're going to rotate it effectively over this diagonal line, like 7, 5, 3 is the diagonal line, right? And we're going to rotate everything over that line. So 8 and 4 are going to swap. As you see here, they swapped in the final output. 9 and 1 are going to swap. So here. Uh, and then 3, since it's on the diagonal that we're rotating over, is not going to be swapped, and 2 and 6 are going to swap. Does that solution make sense?
Okay. Wait, walk me through it one more time. Just need to make sure it's gonna actually work. Let's go back to 741. Okay, walk me through it one last time. Here.
Okay, yeah. So effectively, we're taking the input matrix and we're going to rotate over the middle row. So we're just basically going to take this middle row and we're going to swap everything in relation to that. Just doing like a rotation. So basically swapping this this top row is going to go to the bottom row since it was at the top before. Now it's going to be at the bottom, and the bottom row is now going to be at the top.
Okay.
Uh, so this is the first thing we're going to do, and effectively what this is doing is it's allowing us to do a transpose on the matrix, and that will like a transpose over the diagonal line. Like a transpose is basically just rotating over this diagonal. Uh, there's like a little bit more mathematical nuance into that, but I don't think that's like relevant.
Yeah, how are we gonna do this transpose though? Like two pointers.
Yeah, so effectively what we're going to do is we're just going to go through the rows and columns of the arrays, and we're going to set, and since we're doing this in Python, we're going to do like matrix of row, column, and then matrix of column, row equal, and then we're just going to swap them.
Okay. Okay.
Um, yeah, and that should work.
So this
Uh,
one, could you walk me through like for so this
yeah,
like
yeah, yeah,
yeah,
sure. So this is the matrix after we've rotated it over, right?
yeah.
So effectively we have 0, 0 right here.
Mm.
So matrix of 0, 0, matrix of 0, 0.
Okay. Yeah, so it doesn't change
And
at all.
it's not changing since you're swapping with itself.
Okay.
So that's why these diagonal lines 1, 1, 2, 2, they're always going to stay the same in this format.
Sure.
So here we have 0, 1, right? Um, so effectively we're going to do 0, 1, matrix 1, 0.
Okay.
And we're going to swap those
Okay.
1, 0, 0, 1. So right here we have 8 and 4, and this is going to be your 1, 0. And these two are going to swap. And that's where you get this final output right here.
Final output right there. Okay. Yeah. Go ahead and code that up.
Yeah, for sure. Um, do you want me to make a class or just write the function?
You just write the
Uh,
function. So
okay.
write functions.
Yeah, okay, so we're just going to name this rotate. We're just going to assume it's in a class, just because, you know.
Mm-hmm.
Uh, and the matrix should be in the form of a list of lists. And these are integers, right?
Mm-hmm.
Are we allowed to assume that the input matrix is your integers?
Yeah. We can assume that it's
Okay.
correct and is like valid n by n.
Okay. Okay. Uh, so effectively, we're just gonna say n equals line matrix. So that's just so we can have the variable for n. Don't have to keep typing line matrix out. Um, okay. And the way we're gonna flip this so that we don't like double rotate is we're just going to have 2 pointers. Um, this is the easiest way, in my experience, to uh, just switch arrays like this so that you don't end up double flipping anything like that when you're rotating over a center line. Uh, so we're going to use a while loop. And the reason top is less than bottom is because top obviously starts at 0 since matrices go downwards in their, at least in the visualization of them.
Mm-hmm.
Also, I typed that wrong. Yeah, so what we're going to do is we're going to say for column in range n, and the reason we're saying for column is because the while loop is taking care of our rows. So we're only iterating through each column at this point. So what we're going to do is we're just going to say matrix of top column. I'm going to rename this to call just so it's easier to type. Matrix of bottom call equals matrix of bottom call matrix top call. Does this line make sense to you, like what I'm doing here? So effectively I'm just swapping the top and the bottom. So at this point we have top right here. This is top. Well,
Sure.
I'm just going to go back up to the initial input matrix.
So we're just flipping all the rows, right?
Yeah, basically. Um,
Or like reversing the list.
yeah, effectively we're reversing the outer list. So in this we have top, and then here's our bottom row. So we're
Mm-hmm.
effectively just iterating through this row and swapping these
Okay.
so that we can just rotate it over the center, the horizontal center line.
Is there a fast way to
Um,
do that without looking through all the elements?
yes, potentially, but we have to do it in place. So like it specifically says that we have to do it in place, and we're not allowed to use any extra memory. So we can't really do any swapping of the entire row without using extra space.
Oh, okay. I was thinking we just like call reverse on that initial matrix. If that's what you're trying to
Well,
do.
yeah, I mean that's gonna do the same thing though.
Okay,
The reverse is just gonna do the same thing.
I see.
Uh, okay, so yeah, we're just gonna increment top here, and then we're going to decrement bottom so that we're going up, and then here top and bottom are going to equal the same. So it's going to exit out of this loop now.
Okay, cool. So that's reversing the rows.
Yeah.
Okay.
So then we're going to go through uh, each element in the array, and this is where we're going to do that transpose operation I was telling you about. So we're going to do matrix of row call matrix of call row equals matrix of call row matrix of row call. Uh, yeah, and what this is doing is, like I explained earlier, it's the same thing. It's just rotating over this diagonal line, which is effectively what a transpose is doing on a matrix.
Mm-hmm.
Um, and then we're just going to return the matrix since we've modified it to where it will have the 90-degree rotate. And we can go through this test case here.
Let's go
Just
through a bigger one.
okay,
Test case. Yeah. I'll
uh,
put it in the.
okay,
I'll drop it in here. Yeah, just walk me through it. Let's just prove correctness real quick. We have about like 5 minutes left on this question, so let's see your dry running skills.
yeah, for sure. All right. Sorry, I'm just making these words easier to see.
Yeah, for sure.
Okay, so matrix M. This is the middle matrix. So after this, uh, and effectively, I'm just going to like write it as it's being generated, if that makes sense. Uh, so the first thing is going to equal this, um, and then we're going to have top here. So top equals 0, and then bottom is this one, since we're starting obviously at n minus 1, 3, so right here. Um, so what we're going to do is we're going to go through each column right here. So, and we're going to say matrix top of call, matrix bottom of call, and then we're going to swap them. So we're going to go 15 goes to 5, and then 5 goes to 15. Well, 1 will go to 14, 14 will go to 1, 12, 9, and 9, 12.
Okay.
And this one will go to 16, and this one will go to 11.
Okay.
And then after that is done, we're going to do top plus 1, bottom minus 1. So now top is here,
Okay. And then.
bottom is here.
Mm,
And now what we're going to do is we're going to do the same thing. We're going to go through each column, and we're going to reverse. We're going to like effectively move this list to here, and this list to here. I might have messed up some of the commas, but I think you understand what I'm saying.
yep.
And then we're going to increment top and bottom again, and then top will be here and bottom will be here. And now since top is greater than bottom, well, greater than or equal to is the exit condition, but it's greater than in this case, we're going to exit out of this loop, and we're going to go to this next part, which is the transpose part.
Sure.
So we're going to go through each element, and we're effectively just going to, I think now that I'm visiting this, I think we're going to run into some duplicate issues here. So what we need to do here is we need to only go from, I mean, we can do this 2 ways. We can do it from 0 to row plus 1, or we can go to row plus 1 to n. Row plus 1 to n is more, just makes more sense to me. So that's what we're going to do. We're going to start from the row that we're at, and we're gonna go through the columns past that row, if that makes sense. So just for example,
Like basically what
we're
you're saying is you flip it, but eventually you're gonna flip it back, and it's gonna be back
yeah,
into.
yeah, because it's gonna go through each element twice, and it's gonna do like effectively it's gonna flip it and flip it back exactly.
Mm.
Yeah, so what we want to do is we just want to just avoid that. So we're just going to only do it from row plus 1 to n in the column vector. That way we're not double looping and flipping it back over and just doing nothing to the array. So basically 0, 0. So for row or 0, 0 doesn't even get run. That's also another reason is so we're avoiding the extra processing time of like running through these and doing nothing. So it's another good reason to only do row plus 110. So we have for row and range 0, so we have row equals 0. I'm just going to write this up here. Row equals 0, call equal 1, because that's where we're starting, right? So now we have this one, 0, wait, sorry, no, this one, 0, comma 1. Uh, and what we're going to do here is we're going to say matrix 0, 1 and matrix 1, 0, and we're going to swap these, right? So
Mm.
we're swapping these, and then we're going to go to this next one here, this next column, and we're going to say, okay, we're at 0, comma 2, and we're going to switch it with 2, comma 0. So this is going to be 2, this is going to be 12. Okay, I'm
Mm-hmm.
like modifying the wrong matrix here. But yeah, I think you get what I'm
Yeah.
saying.
Okay. How would you adjust your code here? Do that row plus. Okay, because you're doing row plus one, so 0.
Yeah, so we don't ever do
Okay.
0, 0. We don't ever do effectively. We don't process this or this or this or this.
Okay. I see.
And the reason we don't do that is just because if we do any of these and these, we're double
Yep.
processing. So we're like doing nothing to the array. We're switching it back and forth. And if we're processing these diagonal values, there's no point in doing that because we're not swapping them anyway. Like we're not supposed to swap them. So
Okay.
you're just like wasting CPU time.
I see. Okay. Cool. Let's get into the next question.
Yeah.
I think that code works. Makes sense to me. Um.
Oh man.
yeah.
I just dropped my mic. Did you hear that?
Well, I thought you were saying "oh man" because of this question.
Oh no, I just dropped my
Okay.
mic on my keyboard and it like changed colors and
I
stuff.
see. Okay. So now we're getting to part second question. We have about 20 minutes for this one. So we're given an array of positive integers, and this array is strictly increasing, right? And we're given a k. Return the kth positive integer that is missing from this array.
Hmm. Uh okay. So I mean there's like so we have positive integers strictly increasing order and integer k.
Mm-hmm.
So like obviously the brute force solution is we could just iterate through it linearly. Um and we could just grab yeah, so the kth positive integer is missing from this array. Um okay, I see. So we want 9 because 1, 5, 6, and 8 are missing, and then 9 is the fifth.
Yeah.
And we're using 0 indexing, so if k equals 0, it's going to be like 1 here. Is that right?
Mm-hmm.
Or is it 1 index? Like,
We
is
start
k
at 1.
0 or. Okay, we start at 1. Okay.
So look at the line 75. It has a better explanation. So 1 is missing,
Got it.
5 is
Yeah.
missing, 6 is missing.
Yeah, so it's 1, 2, 3, 4, 5. Okay. Yeah. Got it. Um, yes, and my like the initial thought is we could create a set out of the numbers, and then the we could just go through the um, like we could just go through the integers and then just say if the integer is not in the set, uh, then just mark that as missing, and then we could just count those. Does that so effectively we could go through and we could say, okay, so say we have a length, say we have an array of length 9, right? And
Yeah.
k equals 3. So the maximum number that this can possibly be, and we're not including 0 as positive, are we? 0 is 1 and only. 1 above, 1 and above. Is that
Yeah, it's
correct?
one and above.
Okay. I know people disagree on that. Just want to make sure. So what we want to do is we can effectively just say 1 through 9. This is like the best possible scenario uh, in terms of getting the highest number possible. So then k equals 1 would be 10, 11, and then 12. So 12 is the largest possible number.
Sure.
So we could go for the integers in the range of 1 to k plus n, where n is the size of the array. I'm going to write 2, that way it doesn't look like a minus. We could just go through those integers and just count how many are missing until we get to the kth one, and then just say, okay, we've got it. And then that would be a linear runtime. But
Okay.
I think we can get a logarithmic runtime uh, if we do something where we effectively just keep 2 pointers. So we keep a left and a right pointer. Uh, and then we just go through them and we just perform a binary search.
Mm-hmm.
And basically, if I believe if we do something like, so we obviously have mid equals left plus right
Sure.
over 2. Um, and then it would be something like if array of mid, uh, I think it would be something like this. And then we would want to get the off by 1 error since arrays are 0 indexed and this is going to be 1 indexed.
Mm.
So we want to subtract that 1 and we do less than k. So this is effectively saying if the array value at the middle minus the number that it should be is less than k, then we want to go to the right because that means that we don't have k integers missing on the left side of the array. Does that make sense? Because if there were k or more integers missing on the left side of the array, then this difference would be greater than or equal to k.
Okay.
So what we would do here is we would just say left equals mid plus 1. And then else we would just, I think we want to still, I mean, there's a couple different ways we could do this. But I think just to keep it simple, what I'll do is just say right equals mid. We could do like right equals mid minus 1 and then do like a less than or equal here, but I like the less than just because it makes it cleaner to dry run and just makes sense
Okay.
more.
Let's dry run it on example one here.
Okay. Yeah, so we have two. I'm just
And
going to copy
walk
this
me
down
through
here.
everything you're thinking through. Yeah, when you run it through.
Yeah, so effectively, this is going to be left. Uh, okay, I'm just going to name it
Yeah,
L
just put
for.
an L there. And,
Yeah, and this is going to be right. Um, so what we want to do here is we're going to say mid equals left plus right. So this is going to be our mid. Um, this 4 right here, right? So we're going to say 4. So we have if 4 minus then the index is 2. So 4 minus 2 minus 1 is less than k. And what is k in this case? K is 5 in example 1? Yeah, 5. Then we would go to the left. So 4 minus 2 minus 1, or sorry, we would go to the right. So 4 minus 2 minus 1 is 1. So obviously 1 less than 5. So what that means is that there's only one. Basically, this is this difference here is the number of integers missing on the left side of the array. So if we just take a look here, that makes sense because the only integer missing so far is 1. So this
Okay.
k equals, this difference here equals 1, and that's the number of integers missing on the left side of the array.
Okay.
Um, So yeah, so basically, since there's only one integer missing, the fifth integer missing is not going to be on the left side of the array, so we're going to go to the right side of the array. So now we have L equals mid plus 1. So now we have L equals this one. I'm just going to put this over here so it's easier to read. So does this make sense so far, what I'm doing here?
Yeah. Yeah. Yeah.
Okay. Yeah, so what we're going to do now is we're going to say mid equals left plus right, floor divided by 2. So it's going to be 3 plus 4, so 7 divided by 2, which is 3. So this is going to be our mid. So L and M are the same here. Okay,
Sure.
I'm kind of struggling with the spacing here.
We'll just drop this in this.
Yeah. Okay. So now we have L and M are both on 3, and they're
Sure.
both looking at this 7. So now we have if array of mid. So array of mid minus 1. So 7 minus 3 minus 1, which is 3. And 3, again, is the number of integers missing on the left side of this value.
Yeah.
So it'd be 6, 5, and 1. That's 3 integers missing thus far.
Okay.
So now we have now we have 3 missing, but it's still less than 5, which is what we want. So we have to go to the right side of the array again.
Yep.
So now we have left and right both are at 11, and mid is obviously going to get set at 11. Well, sorry, the indexes are at 4, but the value that it's looking at is 11. So now we have the difference that we're tracking is 11 minus 4 minus 1, and this difference is going to be 6. So now 6 is actually not less than 5, right?
Yeah. Like there's 6 missing there. Or wait.
Yeah, there's 6.
Yeah.
So there's 6 missing before the 11. So it's going to be 1, 5, 6, 8, 9, 10. So since we only want the 5th one, right? We're going to hit this else clause, and we're going to say right equals mid. I think no, this is right. Okay. Yeah. So effectively, what this is going to do now is, well, I don't have it coded out yet, but we're going to be in a while loop in this entire situation here. So it's going to be like while left less than right. And then, yeah, so now we're at a point where left and right are the same. Okay, so we break out of this loop. And then at the end here, so we have right. So right is 4. And k is going to be the difference in the index that we're at and k. Well, sorry, the index that we're at plus k is going to be the kth missing integer. And the reason it works that way is because we found the index where it's basically at the precipice where if you go before it, there are less than 5. So if you go before here,
Mm-hmm.
if you go before this 7, there are less numbers missing uh, than 5. But if you go between these, there are more numbers missing than 5.
Yeah.
So what you need to do is you need to go to this index here, 4, and you just need to add k to it. And
K to it. Add K.
yeah, so here I believe it'll always be right because yeah, 4 plus 5 equals 9, and 9 is your kth missing integer. Um, yeah, and sorry, just 1 second. Okay. Um, yeah. So effectively, what we need to do
I mean,
is we
let's
need.
just code it up. I think you're getting close, but we only have 5 minutes left.
Oh, okay, yeah, we can just
Just
get
code
this
it
out
up.
real
Just
quick.
code it up and then dry run me through the code and hopefully you can catch it there. I think your binary search approach is making sense.
Yeah, so I'm just gonna def
And just talk to your process. I'm grabbing water quick. Keep going.
search array. So we're just gonna search this array. Um, we need k as well. So what we're gonna do here is we're just gonna say while left less than right, mid equal left plus right over 2, uh, if array of mid minus 1 less than k. Oh, it's right here. Left equal mid plus 1, else right equal mid. Um, and then we're going to return right plus k. Um,
Right plus K.
yeah, and this right plus k, it's similar to a lot of other binary search issues where you want to just return the right index after you exit your loop. But the reason you want to add k is just so you offset that missing that kth element, if that makes sense. Because that
Okay.
index is going to effectively be the difference between the kth missing element and k. So this right index is always going to be that when you exit that loop.
Okay. Let's dry run it. 1, 2, 4. We're looking for the first missing element.
Okay. Yeah, so obviously output 3, just so we can have a standard. So left equals 0, r equals 2, and then we're going to say while left and right mid equals 1. So if array of mid, so 2 minus 1 minus 1 less than k. Okay, that's true. So we're going to do left equals mid plus 1. So now left equals 2, and now we're out of this loop. So now we're going to return right plus k, and right plus k is going to equal 2 plus 1, so 3.
2 plus 1 equals 3. Okay.
Yeah.
Let's see. What if we had 3, 5?
Are we still looking
Yeah.
for the
We're
first?
looking for the first.
Yeah, so we're looking for 1 here. So L again equals 0 and 2, mid equal 1. So we go to mid equals this, if array of mid, so if 3 minus 1 minus 1 less than 1, we'll go to the right. Obviously, It's not true. 1, because 1 is not, like, 1 is not less than 1. So we go to right equals mid. So now we have right equals 1. And then we calculate mid equal to 0. And then we will say if mid, or if array of 0, which is 2, 2 minus 0 minus 1 less than k. Again, 1 is not less than 1. So we're going to do, again, right equals mid. So right equals 0. Huh. Yeah, so right equals 0, so we return 0 plus 1, because k equals 1.
Wait, right
Because that's
equals 0.
always...
But right is at okay, right is at the 0th index.
Yeah, so we're returning the right, like the index. We're not returning the value at the right plus
I
1.
see.
We're returning the index plus 1. Because that index is basically the difference between k and the kth missing integer.
But like, what if we? Okay, I think it might work. I'm trying to see if there's an edge case.
I think this should work. Like,
Cause what if the
I
numbers
think
are
this...
like yeah. Let's see. Cause okay, trying to see if there's an edge case. Give me a sec. So if, cause I'm wondering if k here is always the right way to do it. Like, what if we're
I
but
think it should be, because, like, whenever you exit this loop, you're at the point where you're, like, at the balance point, right? Where you're at the best index you can possibly be, and you have this, say this index is 0, and you know that you know that you have 1 missing before 0.
I
So
see.
the first missing before the 0th index, if it's before the 0th index, it's always going to be 1 if this is 1,
Okay,
right?
Alpha had a good idea. Run. We're throwing this into the leak code real quick. So submit. Nice, it works.
Yeah,
Okay,
I figured it would.
nice. How do you feel about your performance? Oh wait, let's see.
I think I don't explain things well. I think that's something I need to work on. I think, I mean, these are really easy questions, but
Really easy questions. Interesting.
I mean, I'm pretty. That last question had to have been an easy. Like, I put money that was an easy.
Okay. What about the
uh,
first question?
the first
Okay.
question, I
Wait.
mean, I know
Let
that's
me.
considered a medium, but it's like a
Yeah.
graph, so it's like
I
fake
see.
medium.
Okay. So you think, yeah, just better explaining.
Yeah, I mean,
Yeah.
I think, like, my algorithms made sense. I don't
Yeah.
think many people would come up with the log n solution to the second problem. I think O
Exactly.
of n is, like, really easy. Uh, I think log n is, like, kind of hard to think of on the spot,
Yep.
especially, like, to think of that right plus k. I don't think
Yep.
many people would think of that,
Nice.
but I could be wrong.
Yeah.
But
I
I
mean.
also don't. I also think it's hard to explain, just because, like, the way I think about it is like a math perspective, and if
Mm,
I try to explain that to any coder, they're just gonna be like dumb, like, just no clue what I'm saying. So
yeah.
it's hard to explain it.
Yeah.
I need to like actually figure out how to explain stuff to people whenever I think about it like that.
Yeah.
I just need to think of, like, the coding way to explain it.
Yeah. No, overall, really good job. Definitely a yes. I'm trying to just think it would be a strong yes. I think definitely a pass, but on the first question, you took about like 20 something minutes. A strong yes would probably be like 10 to 15 minutes to solve that question.
Yeah,
I'd
I mean,
say.
I could have coded that in, like, probably 45 seconds. I just It's, like, hard for me, like I said, it's, like, hard for me to explain that,
yeah.
because
I think,
like,
yeah.
explaining transposing matrices in, like, a dumbed down way is hard for me to do. I don't know.
Mm,
Like, to explain just, oh, we're just rotating over this diagonal array, but
yeah.
that's not exactly what it's doing, but it's
Yeah.
like what it's doing in a visual perspective.
Yeah. Okay. Let me bring up my marking sheet and see if you hit everything, and then I think it was like borderline strong yes. Um, and not just saying that because I like you. You
Nah,
actually was able to hit the good answers. I mean, honestly, that's not a hard. I mean, that's getting log in. If you just look at the discussions, people are so mad about that. Like, it's hard to find log in for that one.
yeah, I
I'll
mean,
just say I
I
was.
could see that. I could see why. If like, if you're not super,
Yeah.
I don't know,
I would say
you're
for
not
the
trying.
rotate, you took a few, like you tried a few things, but you noticed why. But I think you tried like two or three things, and you caught yourself a few times. Like,
Honestly, it's because I'm pretty sure the leak code question is rotate counterclockwise. So I was thinking about rotating it
uh,
counterclockwise.
okay,
So I like reversed it for a second.
yeah. But I think even the part where you like went through the whole list and you would like flip it back, but you eventually caught that. I think you were dry running it, and you're like, oh, we flip it once, and we will flip it back.
Yeah, I mean, in my head, I knew that I shouldn't run it. That I just wasn't like thinking
I
whenever I
see.
was coding. But
Yeah.
like whenever I started running it, I was like, oh, I don't know why I did that.
Like even for 53 here, you could probably have just like reversed like this, right?
I
Or
mean, yeah,
like
you can just like matrix out reverse if you really wanted.
or just not even like per element too, but just like flip the top and the
Oh
bottom.
yeah,
Yeah, like
yeah, you
that
could
would
do
speed
that.
it up a little bit. Like not really in runtime complexity, but okay.
I mean, it
You
definitely
asked
did.
the right questions. You discussed the multiple working approaches. Yes, you pretty much coded up what you discussed, but you had to change things up while you're coding a little bit. That's the one thing where you
Yeah,
said one thing and then on the fly you would catch yourself. So if I were to give a strong yes, I would like want you to catch all those up front, all the edge cases. But that would be like the main thing. And then your dry running was really good. And yeah, overall like that's a pass.
yeah. I like I said, I think I don't think the code. I feel like these are easy questions to be honest, but I think like the coding part, I think is not hard for me. I think it's just the
Yeah.
explaining part.
No, good job. How do you feel about that performance? Are you giving yourself a no strong no yes or a strong yes? Do you think my feedback was valid there?
Nah, I think your feedback was super valid. Uh, I just need to practice more, like do more mocks explaining, because like I can do leak codes, but if I'm not explaining them, I'm
Yeah.
not really practicing what I struggle with.
Yeah, I think yeah, it's super good though. Like you caught all the edge cases. Like even by this modified binary search, like you're capturing. One thing is like 126 in Python it doesn't overflow, but sometimes better do left plus right minus left divided by two. I don't know.
Oh yeah, yeah, that makes sense.
I think also 124 here, your length of array you should minus one, so that would have thrown a syntax error, like little small nits like that.
I don't think I should do that there though.
Which
I don't think I should do. I think I should be doing length of array.
oh okay, oh you're thinking okay yeah because it won't.
Yeah,
Well, I
because
mean,
I'm
your code
storing
did
it.
work. Yeah, actually, what am I saying? Yeah, you're good there.
Yeah, because like it'll never be trying to access array of right.
Yeah, it is not
It's
actually.
not. That's just for the binary search. It's not actually accessing that.
Nice. No, yeah, definitely. If this was meta, you're moving on to the next one. They're gonna do three more rounds just like this. But good job, Paul. I'll see you around on the streams. Gonna grab the next person on there. Strong
All right,
coding
man.
with Minmer says you're a strong hire too. So nice. Sleep good tonight, man. Sleep good. I'll talk to you later.
Thanks, man.
I see you.
See ya.
Yeah, if Minmer says you're in, you're in. Okay, we got we got somebody else coming on. Stay in the chat. We got one of my friends from college. So you're gonna see how how good people in my college are, which is gonna be interesting. Wait, I'll be right back. Give me a sec. Give me a break. I'm gonna take a quick break.